Hi guys, me again. Here to show you how to do the scales of the universe proportions activity. I'll explain some basics, show you the objects that are described on the sheet so you have something visual, and then I'll have a separate video just doing the first example for you so you feel like you know what you're doing. I really like this exercise because it gives you a sense of how vast our universe is by allowing you to compare it to everyday objects, and it also gives you good practice working with powers of 10 and some basic algebra. So hopefully after watching this and looking at the other video I do on example, you'll feel like you have a pretty good idea of what you're doing. Okay, so let's start looking at the objects that we're going to be comparing to.
Okay, so our first object for comparison is the school itself. So if you haven't figured it out, I'm in the courtyard. And so we're going to take many of the astronomical objects that you found and reduce it to the size of the school. So we want to get a sense of how big is the school in terms of, let's say, its length. We're not interested in volume or area, but its dimensions. So if you were to estimate on the powers of 10 in meters, how many is this? 1, 10, 100, 1,000, million, etc. You should be able to settle on this is approximately like this is closer to 100 meters than to 1,000 meters or 10 meters. So on our sheet, we're going to put 10 to the 2 for our size of the school, and that's going to be our important comparison here. All right, so the next objects we're going to look at are in the classroom. So once we come to the school, the next size down would be roughly 10 meters, and that's our classroom. So from one side of the room to the other is close to 10 meters, or closer to 10 than it is to 1 or 100. Okay, now specific objects. So we need something that's roughly a meter, so we're going to use our old friend Huggy Bear. I guess you haven't met Huggy Bear yet. He's our physics bear for many demonstrations. So in terms of his height, he's closest to 1 meter than he is to 1/10 of a meter or 10 meters. So that's our object of comparison. Then we want to go down 10 times smaller. We go to a soccer ball. So a soccer ball is not 10 centimeters or 1/10 of a meter. It's closer to 2/10, but that's closest to 10 to the negative 1 meters as opposed to 10 to the 0, which is the same as 1 meter, or 10 to the negative 2 a centimeter. So there's our next object for represent 10 to the negative 1 meters. Then you go 10 times smaller, we're going to a marble. So a marble is roughly a few centimeters in diameter. A few centimeters is a few hundredths of a meter, so that's 10 to the negative 2. So the next level down, if we go to 100th of that, is a millimeter. A millimeter is 1,000th of a meter, and we're going to use these cute little BBs. So their diameter is roughly 1,000th of a meter. So 1,000 of these would be, end to end, would come to essentially Huggy Bear's height. All right, if we want to go 10 times further still, then we got to go to a 10,000th of a meter. And for that, I'm representing these grains of sand. Okay, so I think we can convince ourselves these are smaller than these, and roughly 10 of these laid end to end would give us a diameter of that. Not exactly, but close enough. And then the last one, I said human hair. I don't have or hair. I'm going to take it from Huggy Bear. Ouch. And if we look at the thickness of that, we might convince ourselves that's 10 times smaller than the grain of sand. Okay, so those are objects of comparison, something for you to be able to visualize when you're doing the maths.
Okay, so let's fill in the information that you saw in the other video in terms of the visuals. We are doing everything as a power of 10 in meters. So the school we said is 2. In other words, 10 to the 2 meters long. The classroom is 1. This is 0. So 0 doesn't mean 0 meters. It means 10 to the 0th or 1 meter. Soccer ball is 10 to the negative 1. Marble 10 to the negative 2. Lead BB 3. Negative 4. And a strand of hair 5. Okay, so again, just to reiterate, 10 to the negative 5 is the same as 1 over 10 to the 5th. That's what the negative exponent does, which is 0.00001. I'm not even sure if that's the right number, but you get the idea. So it's a very, very small amount of meters. Okay, so now the exercise at hand. We're going to shrink things down to smaller sizes so we can visualize them and then get a comparison scaling down. So let's say we took the entire Earth and we fit it into the courtyard of the school. Okay, we shrunk it down. At this scale, how big would a human being be? Okay, so if everything shrunk down proportionally to the fit within the courtyard, how big would we be? And the idea is, would you be as big as the school itself, the classroom, or any one of these. So go ahead and take a guess. Would you be as big as a strand of hair, grain of sand? Put that in there. It's just a guess. Whether you're right or wrong is not really relevant, but it's just kind of get you thinking about it. Okay, so I would guess, we would be a marble. Okay. Could be right, could be wrong. So now we're going to use the powers of 10 and to come up with an idea, an answer that basically we can be very confident of. So the way you approach this, and I've set it up with words, and then we'll put in the numbers and then do the algebra, is how I want you to approach it for all the problems. So we're going to do proportions. So this is how it works. I've already set the equation. It says the ratio of the diameter of the earth to the size of the school, so that's a divide sign, ratio means divide, has to be the same as the human, which we're shrinking down the earth, and so we're shrinking down human. We're shrinking the earth to a school, so we're asking what would a human shrink down to, and that's our unknown, the size of our comparison object. So basically, if I were to do this a different way, I would say the earth is to the school is the same as a human to some object that we want to do. That's all I'm doing. That's the logic behind that proportion. Okay, so now I take my powers of 10. What do we know about the diameter of the earth? Well, on your other sheet, you can look it up. We said that's roughly 10 to the 6th. Okay, we said the school is 10 to the 2. A human, okay, so let's think about that. How tall are we? Are we closer to 1, 10, 100 meters? Hopefully you understand it's 1 meter, so that's 10 to the 0th. And then we're going to divide by 10 to the x, x being the unknown power that we're looking for. Okay, so make sure you understand that before we do the algebra. So now we're going to solve for this. So I'm going to set up using this 10 to the 6th divided by 10 to the 2 equals 10 to the 0 divided by 10 to the x. Now, hopefully remember from algebra, from math, that when you divide exponents, you simply subtract them. So the left side of the equation becomes 4. All right, 10 to the 6th divided by 10 to the 2 is 10 to the 4th. Okay, actually I'll put 10 to the 4th, and we'll see later why I don't really need the 10 part, equals 10 to the 0 divided by 10 to the x, which is 0 minus x, right? I subtract the exponents when I divide them. So since the 10 is common, basically I can say is 4 equals 0 minus x. So I'm going to solve for x. So I'm going to bring the x to this side. I'm going to do it here. 4 plus x equals 0. So x equals 0 minus 4, or negative 4. So our object is going to be 10 to the negative 4th meters in size. So what object is that? If we go up, that's a grain of sand. Okay, so I'm just going to put grain. So that's amazing. So if you can envision the earth fit into the courtyard, a human would be the size of that cute little grain of sand we saw before. And that kind of gives you an idea of how large the earth is compared to humans. Okay, so the rest of these are along this line. For the next one, we're going to start with the universe. We're going to fit into the school, the courtyard, and then we want to compare it to a galaxy. So you have the values for the powers of 10 of universe and galaxy on the other sheet. I want you to make a guess which object, in other words, would a galaxy be the size of a grain of sand compared to the whole universe, or in other words, I've set up the equation for you word-wise. You can plug in the numbers. Please show your work. If you don't show your work, I'm not giving you full credit. And then make sure you put the answer. The answer is going to be the object above. So put soccer ball or marble or whatever the case may be. And then there are 3 or 4 others. Try those, and then we'll discuss those in class. If you have any questions on this, go on to Schoology, ask questions, talk to your fellow classmates if you're not sure of something, collaborate on this. Don't copy. All right, good luck, and I hope you enjoy.